Now that we have learned the concept of sets, we can also start talking about maps. In the previous section, we considered an example where we were reading the text of a book and then searching for the existence of a specific word within that text. Now, what if we change the problem slightly such that we don't want only the existence of the word, but we also want to know how many times that word has occurred in that text? What we need is actually a mapping from a word or a string to a number, which corresponds to the number of occurrences of that word in the text. So we need a mapping from the word the to the number of its occurrences, say 325. Another mapping from the word veil, this time to its number of occurrences, say, which is 14. We can also change the problem slightly and say this time we want to find the phone number that corresponds to a person. So, for example, you have a mapping from the name Tuna Tugcu to the phone number. By the way, this is not my real phone number. Or from the word CMPE secretary to her corresponding phone number. Can we implement this using a list or maybe multiple lists? Remember that a list also defines some kind of mapping, but the mapping it defines is actually between the contents of an element, an entity, and its index, which is in the range from 0 to the size of the list minus 1. But what we need is not such a mapping. So we can have an idea like we keep two lists. One keeps the person's names and the other one keeps the corresponding value we are looking for, the phone number. So for example, you have two lists of say 100 elements, so 100 names. If the person you're searching for is in row say 35, then in the other list you also go to order or index 35 and find a phone number there. This could be an approach, but actually it's not very effective and it's not very useful. So we will come up with a different structure. So actually what we need is such a mapping as we did actually in mathematics. So we have the keys here and we have the values here, and we have a group of mappings from a mapping from Romeo to Montague, another mapping from Tyler to Durden, a mapping from Tybalt to Capulet, but another mapping from Julia to the same value, Capulet once again. So note that two key values could be mapped onto a single value. That's also possible in a mapping. So a map is actually an unordered collection of these relations that associate a collection of element values with a set of keys so that the elements can be found very quickly. Each key can occur only once, so we do not allow any duplicates, and the key maps to at most one value. So the main operations we have would be defining a new mapping by using the method put. So by calling put, you're defining a mapping from some key to its corresponding value. And you also need a method for acquiring the value that corresponds to some specific key. In Java, the maps will be defined as a map with two parameters for the keys and the values. There are two different, as you will remember also map was an interface. So the real implementations are either through hash map and tree map. Of course you can, by the way, of course you can guess from here that hash map and tree map are similar, but hash map is faster, tree map is a little bit slower, but it is ordered. So with the maps, we have some methods that are frequently used. The maps don't implement the collection interface because it's not part of the collection, but they have similar public methods. There is the clear method, which removes all of these key value combinations, the mappings. The method contains key on a map, returns true if this parameter key is defined. Contains value is similar, but this time we are searching for value. If value is in the map, then it returns true, otherwise it returns false. Get, as we discussed earlier, tells us the key that the value that corresponds to this specific key. If this key is not in the mapping, which means contains key, if we had tried it, would give false, but we didn't try it. We directly said get key. In that case, it will return us null. Is empty returns true if the map has no keys or values in it. Key set, when used for a map, will return a collection of all the keys in the map. So actually, it will return these four things here. Put, as we discussed, will define a new mapping between key and value. The value might have occurred earlier with another key. That's possible, no problem. As we did in here again. For example, when you first define Tybalt and Capulet would be added into values. But later, when you say Juliet and Capulet, this time Capulet is already here in values, so there will not be a second Capulet, but Juliet will also be mapped onto the same value. Put all will take as parameter another map and copy all key value mappings from that map to the current map. Remove key will remove the key that's given as a parameter and also its associated value. However, going back to the figure again, for example, if you remove Tybalt, Capulet will not be removed because there is another key that maps to the same value. But when Juliet is also removed, then Capulet will be removed because now there is no one that maps to Capulet. Size tells us the number of key value pairs, and values returns a collection of all values in the map, just like key set. So the maps are declared with two parameters, not one for the keys and the other for the values. So here's an example. We're defining a mapping. In the key set, we will have strings, and in the values, we will have doubles. So we're defining the salaries, for example, as a mapping. Note that, as earlier, we defined this as a generic map, and remember, map was actually an interface. But when you try to construct an object, you either have to say hash map or tree map. Here we say hash map. So the types here were string and double for the key set and the values. So it should be the same here. And we call the default constructor, which just creates us an empty mapping. Then one by one, we define actually mappings, rules between these keys and their corresponding values. one by one. So we define 3 of them and then write it on the screen. So this is what we will get. In curly braces, we have key equals value, comma, key equals value, 3 of them. Now, if you want to search for someone specific, like we say, if salary map contains key Jenny, do we have it? Yep, we have it. This will return true in this case. So we define a variable of type double for salary. And from the map, from the salary map, we call the get method to obtain the value that corresponds to the key Jenny. So that will return 86,753.09 to us. That will be stored in this double variable, so I can just show it on the screen. If Jenny was not here, in that case, we would fall into the else part and say we don't have a record for this person. So, as I said earlier, map is an interface, so you cannot create an object of map, but you create an object of either tree map or hash map. And as you can guess, in the case of tree map, the elements are stored in their comparable order, either the natural order or what you defined using the comparative method. It's slightly slower compared to hash map, and it can only be used on elements with an ordering if you have not defined the ordering, or if the object, the class type does not implement the comparable interface, then there will be no ordering, therefore you cannot use tree map in that case. Hash map, on the other hand, stores the elements according to their hash values, which is an unpredictable order for us. It's faster to add, search, and remove because it's working based on the fast hash functions. So a map itself is not regarded as a collection because it does not implement the collection interface, although in theory it's something like a collection of such pairings, mappings. Instead, a collection views of a map may be obtained for the keys as a set. That's why we have the method name as key set, or a collection for its values. Not that we said set for the keys, but a collection for the values. We don't say set for the values. Why is that so? Why don't we say set for the values, but we say a collection? The reason is actually what we discussed earlier. Remember the case of Capule? There were 2 different keys mapping onto the same value. If it was a set, it would mean that there would be a single occurrence of Capule, and we would not be aware that there was some other key that maps to the same value. So when you remove one of these mappings, it would remove the value, but then there would be a dangling mapping from the other element, say Juliet, trying to map to Capule, but Capule is gone. Therefore, the answer is that there could be multiple keys that map to the same value, and when you remove a key, you may need to preserve the corresponding value since it may be mapped by another key. The map has no iterator method. It does not implement the iterator method. However, remember, the keys can be retrieved as a key set, and the values could be retrieved as a collection. And for the collections in general, therefore also for the sets, we have the iterator. So you can get the iterator for that. For example, you can say you can define an iterator for the keys. Let's call that key iterator as a string because we had strings, for example, for the keys, and say if the name of our map is grades, grades.keyset will return us a set. Therefore, from here we get a set, that set dot iterator. So it will be an iterator that visits the keys in the mapping one by one. If you want to work the other way around, from right to left, from the values towards the keys, you can also do that. This time you define an iterator. In this example, our values are also strings. If it was integers, then here we would have integers. But again, grades, this time dot values, will give us a collection. And for that collection, there is an iterator. So this time it will visit the values one by one. You can also use the enhanced for loop over these collections. For example, you can say for, we're defining SSN, the social security number, as a variable, which gets its values from the values of this SSN map. Remember, SSN, a map variable dot values gives us a collection. So the variable here will get its values from here. So this way we would be actually printing all of the social security numbers in the system one by one. So let's look at an example. In this example, we're defining a map of string to integer. We will call the map with the name M. Remember, map is an interface, and here we're constructing a hash map object for this map. Again, of course, from string to integer. The type of the key set and the values collection should be the same on both sides. And what we want to do is keep actually the birthdays of people. So for Newton, the birthday, of course, the birth year actually is 1642, and for Darwin, it's 1809. So when we display this map on the screen, that's what we get. The key equals value, comma, key equals value. We have only two mappings in this map. Now, let's try to get the key set out of this map. So I'm going to get the key set of M by calling the key set method of M. And I would like to store this somewhere so that I can later make use of it. So I define a set named keys. Remember, this mapping was from the string key set to the integer values collection. Therefore, my key set should be defined as a set of string. And then I define an iterator on this key set. Now I have put the key set in a variable named keys. So I'm calling the iterator of that keys.iterator to initialize it, to initialize an iterator of string. Now using this iterator, I can visit all of the keys one by one. And in each iteration of the loop, with the next method of iterator, I will get a key. Again, remember my keys were string. And from that key, I can find the corresponding value by calling the get method through the M map. So this way, I will be able to print the key versus the values easily. As a practice, try to develop the following by yourself. Write a code that will invert a map. For example, in the previous case, we were looking at the people's birthdays. Now let's try to define, for example, again, a phone book from name to, for example, phone number. The numbers here, since they have the dash, you cannot write them in an integer or float, so you write it in a string. Therefore, our map is from string to string. And what we're trying to do is, actually, we already have the phone book, so we define new mappings. One is sorted by name, actually accessible by name. So you give the name, from the name, you access the phone numbers. And you're given this, try to invert this, which means given such a map, now implement the by phone version of this. So from the phone number, you try to find who this is. So write your code here and try to implement it by yourself. When you implement it, this print line should give you such an output. So implement by phone such that you will get this output. Or you can write a code to count the words in a text file and using a hash map to store the number of occurrences of each word. So this is the end of this chapter. Here you have some previously asked exam questions in CMPE160. For example, this one is from spring 2018 in midterm 1. That's the second question. This is the third question from the same exam. So you have some questions related to this chapter in these slides. So that will be the end of this chapter.